Greetings and welcome to my new calculus channel. My name is John Gabriel. So in the previous 4 videos, part 1 through 4, I gave you 4 different reasons. There are 6 reasons why the mainstream derivative definition of calculus is flawed. And let's quickly revise those 4 reasons. So the first reason is that the definition is circular. You're actually using L in its own definition, okay? So you basically are guessing L, which is this value here, in the inequality or the definition, and you're trying to verify it using this inequality, okay? Because this here means this, okay? They're the same thing. They're equivalent. You can switch the two out. So if you switch the two out, that means you're using this in its very own definition, okay? So it's circular. The second reason is that, let's see, you don't have a concept such as an irrational number. That's just a myth. There's no such thing as an irrational number. Therefore, there can't be a real number, okay? And there is no such thing as an infinite decimal expansion. It's a load of hokey pokey, simply because there isn't. Infinity is a junk concept, and that's why it's a load of hokey pokey. And you can read all about it on this fantastic article on Dietrich and Katz, where I discuss a lot more. So the third reason is that this inequality that you see back here, this inequality here, it's not a proper definition. It's a verifinition, okay? So what happens is you're having to guess L and then try to verify through epsilonics. So if you guess L, then you have to show that using that same inequality that you see up here, this inequality that you see up here, you have to show that this statement is always true, okay? So, but you're using L in its definition. L is the derivative, okay? So it's a verifinition, it's not a definition. The mainstream do not have a valid systematic way of finding the derivative, and that is problematic. Okay, now, the fourth reason is that if you consider this sequence of finite differences, there is no finite difference in terms of f that will ever give you the derivative, whether it's an integer or a rational number, with rational being redundant because all numbers are rational. And the way we can see that is we look at something called the finite difference. So this expression here is simply just it's simply just this value, okay? It's simply just this. It's a finite difference. Okay. So this finite difference is available everywhere except when h is 0. Okay. I could also make this negative, and you'll have some negative. You'll have this line here popping below this red line here. Okay, below this red line. So the problem there is that there is no finite difference sequence which will ever give you the tangent line slope. So this reason number 4 is pretty important, because when you're looking at a non-parallel secant line, like you are in your bogus calculus, what does your bogus calculus do? Your bogus calculus tries to find the tangent line slope by just finding, let's do that, by finding secant lines that are close to the tangent line. But there is no secant line here. There is no secant line here which will ever become the same as the tangent line. And that's why there's no slope that will ever match that of the tangent line. It doesn't matter from which side you approach, from this side or any other side. Your mainstream calculus is a bunch of fraudulent bullshit. That's all it is, okay? So that the theory works is due to the fact that the results are true. But I mean, you can drive a car or pilot a jet or many other things and not know why they work. Just like most of you who become math professors and calculus professors don't have a clue why calculus works. In fact, most of you don't even know that the mean value theorem is the fundamental theorem of calculus, and that you cannot use calculus unless you have a smooth curve, okay, a smooth function. So those are the first 4 reasons. Let's look at reason number 5 today. So what does number 5 say? It says in order for the very definition to work, it must be possible to have a hole at the point of tangency. Okay. And this is mandated by the requirement that both epsilon and delta in the inequality, they call the definition, must be greater than 0. Okay. Namely, in this identity. So you can't, for example, say that goes to 0. It doesn't go to 0 because this here is an equality. Okay, they're all constants. This first part is the slope of a non-parallel secant line. Okay, so if you have a graph like this, let's do this again, like that, and a tangent line there. Okay, then the slope of this line, this red line, is f of x plus h minus f of x over h. The slope of the tangent line, this line here, is simply what we call f prime of x. And the difference is something called the q of xh, which can be an expression in at least one h or more, and it may or may not contain x. So you could write this whole identity as as follows. You could write f of x plus h minus f of x over h is equal to the tangent line slope plus the difference, okay? Plus this difference or minus this difference. Doesn't matter, it's the same thing. For example, if you had a curve going the other way like that, okay, then you might have a negative term, but that's not a problem because plus takes care of everything. Okay, so that is why the for point number 5, you need to have a hole. And what does that mean? This is what it means. It means as you approach this limit point, this bottom statement here, okay, let's go to limit magic. This bottom statement here must be true. In other words, it corresponds to what I'm pointing to here, right? Over here. Where's my pen? Pen. You know, all these GeoGebra things are different and it really annoys the hell out of me. See this definition here? It's what's happening down here. Okay? Right. So now, if you move this guy along here, this arrow here must always imply what follows, right? But if you obviously move out, it doesn't imply that. Okay. And naturally, if you move to a spot where there is no mapping delta, it's also not going to be true. So this inequality doesn't care about the point of tangency because you see this is not true. Uh, zero might be less than that, but 0 is not greater than 0. Okay. and epsilon 0 is not greater than 0, and epsilon and delta need to be greater than 0. And this is what I call the whole feature. Okay, what is the whole feature in mainstream calculus? The whole feature is simply this: is the baboons known as your math lecturers and professors want to have a whole feature, so they fraudulently devised this multiplication by 1, which would knock a hole when x is equal to k. So now all of a sudden, f of x is not equal to k. This is the typical kind of monkey business that people like Professor Jack Hazinger do with sine x over x, okay, which is very well defined at 0, by the way. Why? Because x actually measures sine x. Exactly, by the way. It cancels out with every x that is in sine x. And by the way, sine x didn't have to be defined the way it is. If you look at my ancient trigonometric formulas, you'll see that I have exact formulas for calculating the trigonometric ratios and their inverses and the functions. So it's not like Newton's crappy infinite sequences where you have x cubed minus x5 over 5 factorial plus x7 over 7 factorial. It's not like Taylor series crap. I mean, there's something far more advanced than Taylor series, and it's 100% accurate. It's called a Gabriel polynomial. Okay, and if you look on my academia channel, you'll see a whole article on it. Of course, it's pretty advanced, and most of you are, I'm afraid, too stupid to understand it. But some of you do like math, and you will look into it. Now, you cannot you cannot change the value of anything by multiplying it by 1. Okay, this here can only be 1. It cannot be 0 over 0 because there is no such thing. Okay, that's just nonsense. Okay, it's drivel. No. So what I was telling you is that it's okay as long as it's in this blue shaded region, all right? But the minute you move out of the region or into a part where the delta doesn't map, where the smallest delta doesn't map, then you'll have an error. I'm going to cover this again in the last reason. That's part 6, where I describe what that one Chinese idiot professor did in California, where he was trying to explain these inequalities. I'm going to show you that my geometric theorem exposes the uh, incredible stupidity of mainstream academics and their failure to rigorize calculus. So this is pretty much it for this video. This is part 5, and in part 6, I'll finish up the series. If you're not already a subscriber, become one. Okay, go to my channel and become a subscriber. Follow me on academia.edu. And to get extra information and grow your knowledge by bounds and leaps, you will come to any of the videos that I've created and you'll click on the join button, okay? This join button. And then for a mere €5 a month, you'll have access to information that I, the genius, John Gabriel, do not share with the moronic public, which is most of humanity, okay? So be sure to sign up, become a member, and tell your friends about these things, and your lecturers and your parents and everybody else you know. Spread the knowledge, because mainstream academics do not like me or my ideas, and they do not care whether you understand or not, because they don't understand, and so they don't care whether you understand or not. So until next time, I'm John Gabriel, and this is a new calculus channel.